Hello everyone, today we will discuss support vector regression and we are going to solve a math example. So let's start. First of all, let's start the diagram for the support vector regression. There's upper boundary line, lower boundary line, and in the middle is regression line. So suppose we have three data points 1 1 2 3 3 2, and we are going to find the first regression line. For example, epsilon, which is the parameter for the support vector regression model, 0.2, which is width from the regression line to the boundary. So we will find the regression line wx plus b, and we are assuming that the point 1 1 is on the lower boundary, and for that we will write error equals minus epsilon. Error is observed value take away predicted value, right? So plug in the value of the point 1 1 into this equation and you'll end up with w plus b equals 1.2, and you can assume that the point 3 is on the upper boundary. Repeat the same process, but this time plus epsilon because it is on the upper boundary. Repeat the same process, plug in the values of the point, and you'll end up with the second equation in terms of w and b. 3w plus b is equal to 1.8. Solve these two linear equations and you'll find the value of w 0.3, b 0.9. So using these, you can find the first regression equation fx equal to 0.3 times x plus 0.9. Now this is not the final regression equation. We have to find the value of the objective function and see where the objective function has minimum value. By the way, the objective function is half of slope mod squared plus c times sum of the slack. C is the parameter, and which is called regularization parameter, and slack is the difference of error and epsilon, which is the width. So for each point, data point 1 1, we will find the error by plugging in to the value into the regression equation that we found. For example, here error is 1.2, take away 1, and which is 0.2. So 0.2 is exactly the same as the width of the from line to the boundary, which is epsilon, or we can say that 0.2 error is less or equal to epsilon. It means the point is on the boundary, no slack. The points that are on the boundary or inside, slack is 0. So similarly, you can find the slack for the second point 3 2, and again there will be no slack. Again you'll find error is 0.2. It's on the boundary, it is equal to epsilon, it's on the boundary, so no slack for the point 3 2. The only point 2 3 have error 1.5 using the same observed value take away predicted value. So because the error is 1.5 for the third point, so there will be slack because this error is greater than the width epsilon. So slack is 1.5, take away the width 0.2 equal to 1.3. So if you find the sum of the slack of all points, 0 plus 1.3, so the sum of the slack is 1.3. We will use this sum of the slack in the objective function. So this is the objective function, half of w mod squared, w is the slope, plus c is the parameter, and times sum of the slack. So plug in the values and you'll end up objective function 0.045 plus c times 1.3. 1.3 is the sum of the slack. So c value, regularization parameter, you can choose large value, for example 50, and plug in there and find the value, right? So if the value of the parameter c is large, it means the second term is more important. You're giving more weightage to the second term, sum of the slack side, compared to the first term. So by the way, we stop here. So we cannot reduce the value of the objective function further, because if you change the slope or b from the regression equation that we found, so neither of these terms in the objective function will be reduced. So we can say that this is the minimum value. But by the way, if it is not the minimum value of the objective function, then we will reiterate the whole process by moving the line, and we will stop where there is optimized value of the objective function, minimum value, and that final regression equation would be the regression model for support vector regression. So I think that's a brief introduction. What is the math behind? So thank you very much and see you next time.